welcome to lesson 3.4, where we are going to talk about related rates. Now this is going to apply a lot to what we just did with implicit differentiation. They go together very closely, and you'll see that today. So, related rates are a very common free response question on the AP test. This is something that you're going to end up practicing a lot. So today we're going to just start out with a couple examples. Related rates are always story problems. Now, there's a lot of geometry formulas listed right here in your worksheet or in your workbook. These ones are the most important ones to have memorized. They're the ones that come up the most often. It's also very helpful to have your Pythagorean theorem. That one's very common. And your area. The other ones come up sometimes, but they're not as frequently. These are your main ones. Now, related rates, story problems. It's all about derivatives and story problems, and they're kind of weird. So what I'm actually going to start with is example number 2. I want to start with a story problem right here with you, and then we'll go back and look at example number 1 in a second. So, a windlass is used to tow a boat to a dock. The rope is attached to the boat at a point 15 feet below the level of the windlass. If the windlass pulls in rope at the rate of 30 feet per minute, at what rate is the boat approaching the dock when there is 25 feet of rope out? Write a sentence explaining the meaning of your answer. Now, the first step for these, because on your free response section of your test, they're not going to give you a picture, just like in number 3. And I think, number 4 kind of has a picture. Number 3, no picture. Usually, you won't have a picture there, so you will need to start by drawing a picture of the situation, and then we start to label things. I usually like to do these problems in 3 columns. You have a given column, an implied column, and then a find column. So in the given column, we're going to list what the problem gives us. So we know, let's label these X, Y, and Z. You can label them whatever you want when you make your own picture. But we know that Y is 15 feet. We know that the windlass pulls in rope at a rate of 30 feet per minute. So that is affecting this length right here. We also know that this is a rate. Anytime you see a rate, something per something, that means a derivative, a slope, a velocity. So we're going to say dz dt, which is a fancy word of saying the change of z over a change in time. So we're changing this one over time. It's going to be 30 feet per minute. Now we also know that there is 25 feet of rope out. That's Z. So we know that Z is 25 feet. Now let's talk about what we want to find. It says, at what rate is the boat approaching the dock? So that would be this one. At what rate is that approaching the dock? Now notice that's a rate again, so that's going to be dx dt. So I want to find the rate, the velocity, the derivative of x. So we've got 2 of our columns done. We have given, we know what we need to find. Now we're going to talk about implied. There is a lot of information here that's implied but not directly given to us. The first one is if I know that Z is 25 feet, don't I have a tool to find what X is? I can use Pythagorean's theorem. So if I use Pythagorean's theorem, x squared plus y squared equals 25 squared, and I solve this, so I don't know what x is, y is 15. So I can solve this. So I get x squared equals 25 squared minus 15 squared, which is going to be 400. And then I take the square root. Technically, this is a plus or minus, but we're talking about a story problem, which means you probably aren't going to use the negative, especially because x is feet close to the dock. So I know implied that x is 20 feet. So when there's 25 feet of rope, the boat is 20 feet from the dock. Okay, now I need to figure out some sort of equation that's going to use all this information I've listed. Now I'll tell you right now, if it's a right triangle, you can pretty much guarantee you're using Pythagorean's theorem. So what I'm going to do is take my Pythagorean's theorem again. Oops. But this time, I'm going to take the derivative of it. So I find an equation that's going to link all these variables together, in this case the Pythagorean theorem, take the derivative of that equation. So I'm going to take the derivative of this, and it's very important that I am taking the derivative with respect to time. I want to know per minute. That's what I want to take the derivative of. So I am taking the derivative of all of this with respect to time. So I start by taking the derivative of x, which is 2x. Now we use that implicit differentiation rules. Times by the derivative of x, but this time it's not dx it's dx dt, because I'm taking the derivative with respect to time, plus 2y, and then the derivative of y with respect to time, and 2z times the derivative of z with respect to time. So I've now taken the derivative of all of this with respect to time. Let's plug in what we know. So I have 2, I know that x is 20. I do not know what dx dt is. That's what I'm trying to find. I know that y is 15. Now, dy dt. Let's look at that real quick. That is actually implied. If I have a windlass up here, is the height changing? Derivative is a change of velocity. This height is not going to change. Your windlass stays there and then pulls the boat closer. Here, let me get the video there. Windlass here pulls the boat closer to the dock. So this one and this one are changing. They have a speed, a velocity, changing at some rate. This right here is not changing. It's staying the same the entire time, which means its velocity, its derivative, is 0 feet per minute. It's not moving. So you'll see in these story problems, there's a lot of logic applied to this stuff. So dy dt is 0. 2 times z is 25. dz dt is 30. Okay, let's simplify what I know. I know this is going to be 40 dx dt equals 1500. So I can divide by 40. And here, I'm actually going to move all this stuff over to here. This is one of the best parts of using technology. There we go. So then I can come up here. dx dt equals 37 37.5. Make sure you include your units, feet per minute, because this is a derivative, so it's going to be velocity or rate. So I have found dx dt. But on the AP test, you will always want to write your answer to a problem like this in a sentence. So what we're trying to say, what rate is the boat approaching the dock? The boat is approaching the dock at 37.5 feet per minute when there is 25 feet of rope out. Because we don't know that it's going at 37.5 feet per minute the entire time. It might go faster and then slower, and then faster and then slower. We don't know that. All we know is at this point in time, when there's 25 feet of rope out, this is how fast it's going. That's what we know. So we need to make sure to specify, not only is it going 37.5 feet per minute, it's going that rate at this point in time. So that is your first related rates problem. That was a very long video. Sorry about that, guys. In the next video, we'll try one that is related rates, but there's no story problem attached to it.